Good morning. Today we're going to talk about section 6.4, adding and subtracting polynomials. Well, the first thing we want to do is define what a polynomial is. Before we define polynomial, let me define monomial. Monomial, of course, mono is the Greek prefix meaning one. A monomial is a product of powers, could be more than one, powers of variables, could be more than one, and constants, most times called coefficients. All right, so if I ask for an example of a monomial, well, I could say 3x squared is a monomial because it is indeed a product of powers of variables and constants. I call this a monomial of degree equal 2. Now, when a monomial has only one variable, the degree is the exponent on that variable. Okay? All right, how about minus 7a squared b cubed? That is also a monomial because it is indeed a product of powers of variables and constants, right? This is a product of powers of variables. I call this also a monomial. What degree is it? Well, when a monomial has more than one variable, the degree is the sum of the two exponents. So I call this monomial a degree 5 monomial. Okay? How about, let's see, 4x squared y cubed z. Again, this is a product of powers of variables and constants, so I call it a monomial. Of course, a monomial can have more than one variable, right? This is a monomial of what degree? Well, again, when a monomial has more than one variable, we add up all the exponents to get the degree of that monomial. Notice, z has an invisible 1 as exponent. Right? Z to the first power is indeed equivalent to z. So if I add up all these exponents here, 2 plus 3 plus 1 is going to be degree 6. Common mistake is to call that degree 5. Oh no, please note, this is a degree 6 monomial. Let's see, how about the number, let's say 5. This is also a monomial because I can rewrite 5 as 5 times x to the 0 power, can we not? Anything to the 0 power is 1, and 1 times 5 is, of course, 5. All right, so the constant 5 is also a monomial, and we call that degree 0. All right, so any number is also a monomial, right? Any constant is a monomial of degree equals 0. All right. Let's talk about polynomials now. We've defined monomials. What is a polynomial? A polynomial is a sum of any number of monomials. I could think of a monomial as a sum of one monomial, and a polynomial, meaning many, would be any number of monomials being added or, of course, subtracted. All right, let me give you an example. How about 2x plus 3? I call this a binomial, bi meaning 2, because it's a sum of two monomials, 2x plus 3, two monomials. What's the degree of this polynomial, this binomial? Well, the degree of a binomial or a polynomial is the degree of the highest degree term it contains. Right? This first term here, the degree, of course, is 1. And the second term here has degree equals 0. So the highest degree of these two terms is 1, so I claim that variable expression will dominate the expression for large values of x, so I call this binomial of degree 1. Okay? Let's try another example. How about 3x squared minus 2y plus 9? Well, again, this is a polynomial because it's a sum or difference of monomials. In particular, because it's a sum of 3 monomials, I'll call it a trinomial. Let me erase that. Trinomial. And what's its degree? Well, remember the degree of a polynomial is the degree of the highest degree monomial that it contains. This first term is a monomial of degree 2. The second term is a monomial of degree 1 because there's an invisible 1 on that factor of y exponent. And of course, any constant is a monomial of degree 0. So degree 2 is the highest degree I see here. Oops, what happened? Hence, the degree of this trinomial is degree 2. All right. All right, let's look at another example here. I'll say classify. Here's an example of a test question you might see. Classify the polynomial. Classify the polynomial. And we'll say it's a polynomial in one variable. Well, basically, it's telling me what kind of omial it is, monomial, binomial, trinomial, or whatever, and what is its degree. Well, I've got 4 monomials being added here, 4 terms, where a term is a piece of a sum. All right, so after trinomial, we really don't give it special names. I'll call this then a 4-term polynomial. And what's its degree? Well, remember the degree of the polynomial is the degree of the highest degree monomial it contains. This first term has degree 3. The second term has degree 2 because the 2 is the exponent on that variable. This third term is degree 1. And this last term is a constant that's degree 0. So clearly the highest degree I see in this sum is degree 3, so I claim that is the degree of the polynomial. So I call this a 4-term polynomial of degree 3. All right, let me briefly review the rules for identifying a degree. If you've got a monomial in one variable, the degree equals the exponent on that variable. Okay? If you've got a monomial in several variables, the degree is the sum of the exponents and if you're looking at a polynomial, then the degree is the degree of the highest degree monomial it contains. All right, so look at some polynomials. If we can have monomials with more than one variable, we can have polynomials in more than one variable. How about 3x squared y minus 2x squared y squared plus 3xy. I'll leave it like that, right? So I'll say classify the above polynomial. Tell me what kind of omial it is, and tell me what degree it is. Well, clearly I've got 3 terms, 3 monomials being added up here. So I'll call this a trinomial. And then we'll ask, what degree is it? Well, this first term has degree 3. Right? That's a degree 3 monomial, right? When there's more than one variable in a monomial, you add the exponents. Don't forget about the invisible 1 on the y. Right? This term is degree 4 in that monomial. Right? When it's more than one variable, you add the exponents. Right? This term has degree 2. All right, so let's see, degree 3, degree 4, degree 2. Which is the highest degree? Well, it's clearly degree 4. So I say this trinomial has degree 4. And indeed, this term will end up dominating the expression for extremely large and extremely small values of x and y. All right, I'm going to speak in wide strokes here when we talk about adding and subtracting polynomials. To add or subtract polynomials, in wide strokes, all we do is combine like terms. Combine like terms. What do I mean by like terms? Well, like terms, as you probably know, are terms that have the same exact variable portion in their expressions with perhaps different constant terms or coefficients. And let's jump right in and do an example here. I'm going to do example 1 from our text on the bottom of page 373. It tells us to add 4x squared plus 6x plus 3 plus 2x squared plus 5x minus 1. All right, here we are asked to add 2 trinomials. All right, the first one is a trinomial of degree 3, and the second element is also a trinomial of degree 2. Sorry, this is I said degree 3. This is a trinomial of degree 2. And this is also a trinomial of degree 2. 2 is the highest exponent I see on any term in this single variable polynomial, right? All right. How are we going to add these? Well, I'll just combine like terms. Addition is commutative, addition is associative. So what I can do is group like terms together. I can group the x squared terms together. I can group together the x terms, 6x plus 5x, and I can group together the constant terms, plus 3 and minus 1. Most times we don't take the trouble to write all this out. In our heads, I suppose we could say 4x squared plus 2x squared. Well, when you're combining like terms, you keep the variable portion and add or subtract the coefficients as indicated. All right, so 4x squared plus 2x squared is 6x squared, plus 6x plus 5x is similarly 11x, and of course 3 minus 1 is plus 2. All right, so to add polynomials, simply combine like terms. All right, let's look at example 2 on page 374, right at the top of the page. Again, we are asked to add two polynomials, two trinomials, in fact. All right, notice there's a b. There's two variables floating around here. 5a squared plus 3a plus b. There's a b there, and a squared minus 7a plus 3 is no b here. This is a trinomial of degree 2 in one variable. All right, let's group together whatever we can here. Well, 5a squared and a squared are like terms, and I can add those together. 5a squared plus 1a squared is 6a squared. Takes care of the a squared terms, right? How about the a terms? 3a minus 7a is minus 4a. Keep the variable part and add or subtract the coefficients. Plus, well, b doesn't combine with anything, so I'll just carry it down. And plus 3, that doesn't combine with anything either. So there would be my final answer there. 6a squared minus 4a plus b plus 3. All right, let's do a little nastier one here. Example 4 in our text on page 374. And it's going to take a minute to copy this down. Give me a minute. 3x squared y minus 4xy plus y plus x squared y plus 2xy plus 3y. Let me make sure I copied this down right. 3x squared minus 4xy plus y. This is a trinomial of degree 3 because the sum of these exponents is 3. This is a trinomial also of degree 3 because the sum of these exponents is 3. All right, so x squared y plus 2xy plus 3y looks good. All right, these two terms, these two monomials, have the identical variable portion and different coefficients. Well, I'll just keep the variable part and add the coefficients as indicated. 3x squared y plus x squared y is going to be 4x squared y. And I like to cross these out once I've dealt with them. How about the xy terms? Notice there's a couple of different xy terms with different coefficients. Those are like terms. Minus 4xy plus 2xy is going to be minus 2xy. Takes care of those two. And y plus 3y is plus 4y. That's 4x squared y minus 2xy plus 4y. Okay. All right, next example 5, again on page 374. Now, the book advocates what they call a column method. I don't insist on it. If it helps you to line these things up in columns and add, that's fine. Add 5x squared minus 9x minus 3 and minus 3x squared minus 4x plus 6 using columns. Well, all that means is you pile one on top of the other, making sure like terms are in the same column. Makes them a little easier to add, I suppose. Let's add the x squared terms. 5x squared plus a minus 3x squared gives me a 2x squared. Keep the same variable portion and add or subtract the coefficients as needed. Minus 9x minus 4x is minus 13x. And minus 3 plus 6 gives me a plus 3. Final answer, 2x squared minus 13x plus 3. This is what they call using columns. And some books call it the column method. Again, not mandatory, but you might want to use it, especially in more difficult problems. All right. Let's look at example 6. Again, at the bottom of page 374, they want us to add. Again, they want us to use columns here. Add, let's see, 5w cubed plus 2w minus 4. That's a trinomial of degree 3. And 2w squared minus 6w minus 3. Let me write that down. 2w squared minus 6w minus 3. All right, the reason I didn't line these up in columns right away is because I see this is a degree 3, this is w to the third power, and this is a degree 2 term. These are not like terms. All right, so they cannot be combined with a simple addition. So if they want us to add it with the column method, well, what I've got to do is I've got to make a w cubed column and a w squared column, so I'll leave room for that, and a w column and a constant column. All right. So when I combine now, well, 5w cubed, well, that doesn't combine with anything. I'll carry it down to the final answer. Plus, well, 2w squared, that doesn't combine with anything either. Right? And then the w terms do combine. 2w minus 6w is minus 4w, and minus 4 minus 3 is minus 7. So my result is a 4-term polynomial of degree 3, again with 4 different terms. All right, how do I subtract now polynomials? Well, what I'll do is take that subtraction symbol that appears and distribute it through the subtrahend or whatever you're subtracting. All right, here we are asked here, this is example 6 on page 375. Example 6, page 375. What I'll do here is negate this entire polynomial sum by changing the sign of each term. In other words, distribute this negative sign across this polynomial that you're subtracting. The first polynomial, there's nothing going on outside the polynomial expression on the left, so I can drop those parentheses of the first term and then distribute this negative sign here. Negative x squared is negative x squared. Negative 3x is positive 3x. And again, minus plus 4 is negative 4. So just carry this negative sign through, distributing it, changing it into an addition problem, and now we can just combine like terms. 3x squared minus x squared is 2x squared. Takes care of those. Minus 2x plus 3x is plus 1x, or just x, and then 5 minus 4 is plus 1. So it takes care of all 6 of those terms combining, and this is my final answer, 2x squared plus x plus 1. All right, let's look at example 7 on page 375. All right, they want us to subtract one polynomial, 3x squared minus 5x plus 3 from another, namely x cubed plus 2x plus 6. All right, don't be confused by the wording here. Subtract something from something else. That means we're going to start with this expression and subtract this expression. So this is the one that's going to have the negative sign in front of it. If I write this in a different form, all right, subtract minus 3x squared minus 5x plus 3 from this polynomial expression here. Okay. All right. So now I can turn it into a problem much like the other. I will distribute this negative sign, carry this negative sign through that second polynomial. I can drop the parentheses on the first polynomial because nothing's going on outside of it. Here I get a minus 3x squared is plus 3x squared. Minus 5 is plus 5 plus 5x. And minus plus 3 is minus 3. All right, now I can combine like terms, but I got to be a little bit careful. I'm not going to bother with the column method here. I'm just going to say I have an x cubed term and no other x cubed term in this expression. So I'm going to have an x cubed that carries through. X squared, well, if you see there's a degree 2 term, there's no other degree 2 term here. So that will carry down to the final answer. The x terms can combine. 2x plus 5x is plus 7x. Takes care of those two. And 6 minus 3 is, of course, plus 3. All right, so I've combined all that I can here, and I end up with a 4-term polynomial of degree 3. All right, again, the wording is somewhat similar in example 8. Again, this is on the bottom of page 375. It says, subtract something from something. Subtract 2x squared minus 4x plus 6 from 4x squared plus 5x plus 8. All right, that means I'm going to start out with this expression and subtract this expression. So let me write this out. Well, I can write it out in a column fashion. 4x squared plus 5x plus 8. And from this, I want to subtract this expression. So I'm going to say minus 2x squared minus 4x plus 6. All right, of course, what I'm going to do is distribute that negative sign through that second polynomial, and I'll see that all my like terms are landed in columns. I'll have 4x squared plus 5x plus 8. Downstairs, I'll get minus 2x squared minus 4x is plus 4x, and minus plus 6 is minus 6. All right, now I'll add the like terms. 4x squared minus 2x squared is positive 2x squared, adding those coefficients. 5x plus 4x is 9x, and 8 minus 6 is, of course, positive 2. Final answer, 2x squared plus 9x plus 2. All right, last example today, example 9. This is on page 376 in our text. Subtract 2x squared minus 6 from minus 3x cubed plus 4x minus 3. And they want us to do it with columns. Well, I'm not going to bother with the columns here. I'll just start with this expression and end up subtracting this expression. So I'll put a negative sign in front of that 2x squared minus 6 polynomial. All right, let's start with this then, minus 3x cubed plus 4x minus 3. And from that, I want to subtract 2x squared minus 6. So again, I won't use the column method here. What I'll do is distribute that negative sign to that second polynomial, minus 3x cubed plus 4x minus 3. I'll get a minus 2x squared, and minus 6 is plus 6. And now I'll just combine the like terms that I have left. Let's see, x cubed, I have no other x cubed term. So I'll just carry that down to my final answer. Similarly, I have no other x squared terms right here. All right, I'll just carry that down to my final answer, minus 2x squared. Takes care of that. 4x, I have no other x terms. Right? So I'll just carry down a 4x plus 4x into the final answer. And finally, minus 3 plus 6. Well, those are the only two terms that combine. Minus 3 plus 6 is, of course, plus 3. So there's my final answer, subtracting polynomials. All right, we're at about the 34-minute point, so we'll call it a day. This concludes section 6.4, addition and subtraction of polynomials.